doing an introduction to Kubernetes and Rancher 2.0. Welcome. I am Matthew Shear. I'm a community advocate for Rancher Labs, and our technical engineer on the line is Jan Bruder, Field Engineer in Germany. Thanks for being on the call today, Jan. Super happy to have you. And so everybody, my Twitter is here and Jan's is here as well. So if you have additional questions after the session, feel free to reach out to us. One of the guarantees of these trainings is that we will just be answering a bunch of questions. Our goal is to go through a technical introduction to Kubernetes using a Rancher 2.0. We'll have slides, but we're going to keep them to a minimum. And then just really walk through the product, walk through Kubernetes, help you understand how to work with that orchestrator using Rancher, and answer your questions. So you can start putting them into the chat now, and we'll get to them as we go. Jan will take periodic breaks to answer questions, and really try to, one request from us is just to try to keep your questions relevant to this training material as much as possible. And so on that note, for this training, we kind of assume that you have a basic understanding of Docker. And if you don't, there are a lot of great resources on the Rancher blog and in our docs as well. So on our docs for getting started with Rancher is here. You don't have to copy down this link. We will be sending out the slides and a recording of this session after the session is over. So you'll get that in your inbox, your email inbox, hopefully within 24 hours, definitely by, end of day tomorrow. So if you miss anything, or you have another meeting, work meeting or something like that, don't worry, you'll get this and be able to refer to it afterward. One other resource I want to tell you all about, our forums are really active. They're another place where you can, ask additional questions, things that come up while you're playing with Rancher, trying out your deployments, adding and provisioning clusters, and all sorts of things. Issues you run into or ideas you want to get feedback on. Our forums are great. Not mentioned here, but also a really good resource is our Slack channel, slack.rancher.io. The link to that will be at the end of this presentation in the slides as well, so please stay on. To the end, we have some other upcoming events and cool resources to tell you about at the end as well. And so on that note, I think I'm going to go ahead and we're going to get into the material, and I'm going to hand this presentation over to Jan to take you guys through. Jan, are you ready?
I'm ready.
All right, great. Yeah, I'm going to hand this over to you.
Okay, just let me know if you can see, if you're able to see my screen.
Yep, can see it.
Is it showing up? All right, great.
Yes, sir.
All right. So before we get into all the good stuff, I just want to start up talking a bit about what we're trying to do with 2.0. So Rancher has I think shipped Kubernetes as early as 2015. And you were able to deploy Kubernetes clusters and manage and upgrade them very easily. And in the last year, especially in the second half of last year, we really saw that the Kubernetes momentum was really taking off. So we saw a growing interest in Kubernetes all over the industries. And what people really liked about it was the scalability and the design patterns that were used in Kubernetes. And we are now seeing a large number of software companies embracing Kubernetes, and also many IT vendors are now offering managed Kubernetes services. And if you just look at the product itself, a lot of companies actually are committed to contribute to the project. So this is just the statistics for the GitHub commits by companies. So you can see we have Google, Red Hat, Huawei, and a lot of other big companies in there. And so as I said, we already have a number of users that are running Kubernetes with Rancher 1. And these are some of the challenges that these users faced. Not only running on Rancher, but especially if you build a Kubernetes cluster like from scratch. So one of the challenges was there's so many ways to deploy a cluster, depending on whether you do it on premise or in the cloud, or in bare metal and so on. So how to make it consistently across all these different infrastructures. And another challenge was the access control. So if you are running multiple clusters, how do you hook it into with your central authentication system? And then also, how do you manage roles? Kubernetes has a very advanced RBAC subsystem, but we found that it's actually really hard to make this work at a scale in production. And another question that came up a lot was, how can I partition my cluster so that I can more efficiently use the resources? So in Rancher 1. We had this concept of environments, which were actually basically isolated groups of resources, like compute nodes. And you couldn't really share those between teams. So if you were basically not able to have an isolation between different teams so that they could not interfere with each other's workloads, and at the same time use the same resources. So this is something that we are addressing in Rancher 2.0. And of course, also how can I make my Kubernetes cluster highly available? That is also not an easy feat. And then how do I manage and sync security policies? So network security policies and pod security policies, how do I enforce them across different clusters? And then finally, the monitoring side. So how do I make sure that I have enough visibility into my Kubernetes deployment and also in my app workloads to make sure that everything is up and be able to troubleshoot if an issue arises. Another challenge that people are facing with Kubernetes is the very fast pace of its development. So the Kubernetes project on GitHub is one of the top 5 projects in terms of developers and commits. And if you look at the release cycles, you can see that there's a new minor release every 3 months, and minor is not really what it actually is. So there are changes in the API. There are new features even in the minor releases. So this happens every 3 months. And what that means, if you're running Kubernetes in production, it's a very short iteration of qualifying a new release and then rolling it out into production. So this binds a lot of resources on your side if you're managing a vanilla Kubernetes cluster. And then also, finally, the usability challenges in Kubernetes. So a lot of people are familiar with Docker and with Docker compose files and such. And these are actually, I would say, pretty easy to understand. But with Kubernetes, you get introduced to a whole new configuration scheme because there are so many layers of abstraction in Kubernetes. And these Kubernetes configuration files, or manifests, as they're called, they have quite a pretty steep learning curve. You cannot really leverage like prior knowledge about Docker Compose files to use them. So if your goal is to get your team, your DevOps team, up to speed, and you want them to push product, push code, and not spend time learning Kubernetes, that is actually another challenge for the usability side. So with Rancher 2.0, we really like to address all these challenges that I just talked about and provide you with an easy interface, both for the deployment and also for the workload management on your Kubernetes cluster. And Rancher 1. Was already kind of multi-cluster because with a single Rancher instance, you could manage multiple environments on different cloud providers. And this is going to stay the same with 2.0. So with a single Rancher deployment, you're able to manage multiple Kubernetes clusters, no matter where they are deployed. And we are still shipping our own Kubernetes distribution. So this means that you can be sure that this works on Rancher. And on top of that, we're providing a better user experience for the management of workloads, role-based access policies, network policies, pod security policies, and project management. So if you are familiar with Rancher 1.0, this is kind of like an illustration of the different levels in Rancher 2.0. So just like in 1.0, we are still supporting all the different underlying physical layers. So you can use all the big cloud providers. You can use on-prem clouds like OpenStack or vSphere, and you can also bring a bare metal host into the game. And then on top of that, we also support all the managed Kubernetes offerings. So this is something that Amazon, Google, and Azure are currently offering. Basically, it's a managed Kubernetes cluster where you get an SLA on the Kubernetes API. And then on top of that, we we manage the provisioning of both the physical infrastructure. So we can provision hosts in AWS and all these cloud providers, and then install Kubernetes on top of them. Rancher manages the upgrades of Kubernetes. It manages the RBAC across all clusters, and the network policies and pod security policies. And then the next level is the application management. So we provide the users with an easy-to-use interface to launch and manage workloads. And we have an app catalog. And what is new in 2.0 compared to 1.0 is also that we have a very good integration with for CI/CD monitoring and logging, and we're going to get to that when we do the demo. So this is a picture I want to show quickly, especially if you come from Rancher 1.0. This illustrates a little bit the changed application design of Rancher or physical infrastructure. So you can see that Rancher itself is actually running on top of a Kubernetes cluster. And when you run it is still shipped as a container. So if you run that container, it will basically be, you would get a Kubernetes cluster. And for HA mode, you can deploy a Rancher on top of an AJ Kubernetes cluster as well. So and then that is on top of that picture is basically the core Rancher install. And then it manages, like what you see below is basically 2 clusters. So on the left side, it will be a cluster that is deployed by Rancher itself, for example, on bare metal with RKE, which is our own Kubernetes installer. And then the right side, you can see this would be like a Google Kubernetes cluster, and you can manage all these clusters from one Rancher instance. So you have a single pane of glass for all of that. And next on, I want to go through some of the basic concepts in Kubernetes. So this is just something you need to get familiar with. Kubernetes does a lot more automation than just the plain Docker or Swarm or whatever. And with that higher level of automation, it becomes a little bit more complex. And there's also a lot of how do you say? A lot of abstraction in Kubernetes itself. So you need to learn about a lot of different resource types. And these are kind of like only the top 5 resource types that you want to know about in the beginning. So let's start with the pods. So the pods are basically the smallest atomic unit in Kubernetes. And it's basically like interacting with a container. Instead, it's kind of like an abstraction layer on top, because it can consist of more than one container. And the important thing about it is that all the containers that make up a pod, they share the same network namespace, so they can speak to each other via localhost, but they can also not expose a bind to the same port, because they share the same network namespace. Normally, like in most of the use cases, a pod would just have one container, but there are cases where this this pod resource is actually quite nice, because you can do stuff like have a sidekick container that provides some initialization for your application, or does some setup, or provides a configuration and things like that. So this is actually a nice concept, these sidekicks, because you can kind of augment your application image without altering the image itself. And yeah, so as I said, just think of the pods like containers. In Kubernetes, you don't really interact with the containers itself. So this is the smallest unit that you're ever going to interact in Kubernetes. Yeah, and then on top of that is a replication controller, formerly, and now a replica set. So that is basically a higher level on top of the pods. And what these do is, in this replication controllers and replica set, you define the desired scale and the state of the pods. So you declare all the pods properties, and you tell it at what scale, how many pods do you want to run from a given workload. And the replication controller are basically what is the source of truth for Kubernetes to drive the current state to the desired state. So in Kubernetes, you have these controller managers that are running on the master nodes, and they use the configuration in the replica sets to know what the desired state is for a given pod. And yeah, so normally when you create a workload, you can use these replica sets to do that. It works just fine. But if you want to have some advanced features, what you actually should do is use a deployment, which is basically something that manages replica sets. So it's another level of abstraction. You declare a deployment, and you don't really have to bother about the replica sets, because the deployment is managing those. And what the most important feature of the deployments is that they allow you to perform rolling upgrades for your applications. And yeah, so the next resource that is important to know about are services. So services basically define how your application can be accessed on the network level. So and they also allow you to have a service discovery, so that you don't need to know like what is the IP of a specific pod, but you will just access your application using a DNS name. And there are different types of services. So node port, this means that the application is exposed on a randomly chosen port on all of the nodes in the same project, namespace. And the cluster IP means that the application is just accessible internally. So this would be used like for different tiers of an application that need to communicate internally. And but it still works kind of like an internal load balancer. So you just get one fully qualified name, and you access the application using that name. And then the third type is a load balancer. So this can actually provision, if you're running like in AWS or Google, this can provision an infrastructure load balancer. Like in the case of AWS, this would automatically provision an elastic load balancer for you. Yeah, so these are the different types of services. And basically, if you have deployed a deployment, and then you want to set up network level access, you need to create a service as well. And the next thing is config maps. So previously, like on Rancher, on OneDot, and in Docker generally, the way people configure their images or their containers is usually environment variables, which is not a very good way to do it because you couple basically the configuration with the properties of your container. So what these config maps do is they basically decouple the storage of the configuration and then allow you to provide your pods with the configuration as either environment variables, or you can write them also in a volume in the container. And lastly, they're the ingresses. So ingresses define how a traffic from outside your cluster is routed to inside the cluster. So basically, most of the time, an ingress is implemented by a load balancer, but it could be any other thing. It could be even a router or something like that. But these kind of ingresses, they allow you to set up route-based load balancing and stuff like that. Yeah, so next on, we're going to do a walkthrough to Rancher 2.0. And in the meantime, if there are any questions, we can address them.
Yeah, Jan, there is a question from Dan. I'll read it. It's a little long, and I think you probably might not answer it right now, but talk about it maybe when you talk about ingresses. And here's the question. Rancher 1.6 used to have pretty intuitive workflow when it came to load balancing. Domain name would point to the host, load balancer listening on port 80 on host would then be based on rules, forward the traffic to the container ports. Can you cover load balancing with Rancher 2.0 Kubernetes without cloud-based load balancing? I'm missing the analogy.
Oh yeah, sure. We can definitely do that.
Awesome.
Yeah, I'll do that.
Awesome. Here's another question from Andreas. Andreas, how can I save my configuration on the current Rancher beta server? So in the online docs, no volumes or something else was found. I'm not sure what the last part means.
Oh, you mean he probably refers to the state of the Rancher instance itself. Yeah, so I think there should be a volume created, but you probably have to mount it when you start the Docker container. I'm not sure how it is in the preview beta. I think this is probably a question that we can answer on the Slack channel. So I'm not able to answer that right now.
Okay, cool. Okay, I think that's good. There's one other load balancer question, but maybe when you get to that topic, we can talk.
Okay, cool. So going forward, can you still hear me? Hope
yes.
I'm not muted. Yeah.
Yes.
Okay, so going forward, just going to cover setting up the Rancher, creating clusters, talk about authentication and security, storage, what are projects in Rancher 2.0, namespaces, catalogs, and the CLI API. Yeah, so let's just get started there. Okay, so the first stop, if you want to follow along, from your computer, the first stop would be this quick start guide on our website. So this shows you how you can deploy a Rancher 2.0 instance using Docker. So Rancher 2.0 is still shipped as a Docker image, just as it was in OneDot. And yeah, so you should have at least 4 gigabytes of mem for the node that you're starting the Rancher server container. And these are the requirements for in case you're having security groups and stuff like that. So you can see they're a bit more than it was before because of all these new components that we are running. Yeah, so for the master node, this is list for the master node. So canal refers to the overlay network. So this would have previously been what we had in OneDot with IPsec. And yeah, then you have the port for the Kubernetes API server. So this needs to be open for you to be able to access the kubectl, the Kubernetes API with the kubectl, and yeah, then for etcd and kubelet API. And the worker nodes, they don't have as many services, so again, they need the overlay network port open, the kubelet API, so that is the API that like exposes the node API, and the kube proxy is what does the network forwarding. Yeah, so if you have set up a host like that, so all you got to do, it's like in OneDot, you just run this command. So here I think, yeah, so this should be host. I should have Docker installed here. Yeah. So start this image, and then probably takes a little bit time to start up. Yeah, let's just continue go through it. So okay, so while this starts, do not lose any time. Let's just go to this install that I created before. So first thing that you see, if you log into a new instance, it will prompt you to set your admin password. So your installation is then secure by default. And then I just want to go over the options on the different levels that you have. So right now, for you would not have any cluster, of course. The first thing that you want to do is set up your authentication so that other users can log in. And currently, so in this beta version, we have support for AD and for GitHub authentication. Going to GA and further on, we're going to add more auth providers like OpenLDAP and single sign-on SAML and other things. So right now, these are the ones, external providers that are integrated. And by default, so this is also other than Rancher 1.0, by default, you always have local authentication. So in Rancher 1.0, this was not the case. Once you switch to an external authenticator, you did not have local authentication. So by default, you have local auth, where the users are basically stored in the etcd backend. So if you go now to users, we could start adding another user. Okay, add myself. You have also this ask users to change password and first login. I can make myself an admin. So we are now on the basically administration level, which is called global here. So an administrator on this level would be able to manage the full installation in all the clusters that are in here. So once you've done that, let's look at some other stuff that is new from 1.0. So pod security policies, this is another concept from Kubernetes. Basically, they allow you to define what your pods are able to do. So these would address stuff like, do I want my pods to run in privilege mode? What kind of capabilities on a fine-grained level do I want to allow my pods? Or otherwise, do I want to allow my users to create pods with? Do I want to allow host bind mounts and stuff like that? So this is really to tighten security. And these pod policies, when you create them, you can then attach them to projects. Yeah. Then let's check out the roles here. So as I said, Kubernetes has a very advanced RBAC subsystem, which is also quite difficult to configure in Kubernetes itself. And it's also done on a per namespace level in Kubernetes. So if you want to use these roles in all your namespaces or different projects, doing that with Kubernetes alone requires a lot of effort to sync these profiles across the namespaces. So this was what Rancher basically does then for you. You have a couple of default roles. So you could give your user a read-only role. Yeah, you could allow them to manage workloads or not, manage only storage, stuff like that. You can also create your own roles, and the nice thing is that you can inherit roles and then additively create a new role on top of that. Yeah, so these are, when I said the RBAC system is quite extensive, so this is what I meant about it. So these all are API, basically API resources, where you can define the CRUD access that you're granting to them. So yeah, so you could, for example, create a role that only allows access to specific projects, specific applications, stuff like that. Yeah, we have covered the users. So let's just start by creating a cluster. Have a look at this page now. Okay, so here we are. So when you create a cluster, that means it's a fully sufficient Kubernetes installation. And these are different cluster types that are supported. So starting off, these three are basically the managed Kubernetes offerings of these cloud providers. So they allow you to provision, for example, a new container engine Kubernetes clusters out of Rancher, and then have Rancher manage that. The other options are you can just provision VMs, like you would have done with Rancher 1. On these cloud providers, and then Rancher would install the Kubernetes clusters on these VMs. And yeah, and next on the custom one is the one where we have support for bare metal. So this basically gives you Docker run commands for your different roles for your nodes, and then you just run them on your bare metals, or have your provisioning scripts do that, or whatever you have. And then finally, we also support import of existing Kubernetes clusters. So this would be done here. And a nice thing, so this kind of like provisioning, we did this in one dot, besides the managed Kubernetes clusters. The nice thing that we have now is so-called node templates. So this is where you can define basically the kind of nodes that you want to provision on a specific cloud provider, and then reuse this as a template. When you create new clusters, or when you scale your cluster up by adding new hosts. Yeah, so if you look at this, we could, for example, use DigitalOcean. And then you would be able to say, okay, I want this template should cover Frankfurt, and I want this kind of droplet. And you can also add labels here. This is pretty cool as well. So this could be a label like region Frankfurt, or it could be a label like telling you about that this is a node with a high IOPS, stuff like that. And then you can leverage these labels to schedule your workloads in Kubernetes. So it's quite nice. Yeah, so right now we can just create this one. And I should probably have given it a name, but yeah, it's good. And then when we're going back to the cluster, global cluster level, we can then go to add cluster, choose DigitalOcean, and then right away we can add members to that cluster if you want. And we can also change the cluster options. So most importantly would be like the network provider here. So by default we use Canal, which is basically a combination of the two above. So what this would do is provide, so Flannel in this case would create an overlay network, VXLAN based. And then on top of that, you would get the Calico network policies, which gives you very powerful means to enforce rules, which pods, which containers should be able to talk to each other. And yeah, so we can just leave those as a default. And then, so here it gets a bit interesting. So what we are going to do now, we are deploying nodes that will both run the Kubernetes cluster. And with cluster, I mean like the control plane, the etcd plane. The control plane would be what is often referred to as the master nodes. So this would have the Kubernetes API server, the control manager, the scheduler. And then you have the data backend, which is the key value store etcd. And we kind of show you like what are the minimum requirements in terms of numbers for those. So basically, to give you an example, is I could create a node pool called demo data store, and then give it a count of 1. That would be the minimum. The next would be 3, because for weird reasons, etcd always needs a quorum with uneven numbers. And then I would choose my template that I created before, and this basically tells then Rancher to run etcd components on that node pool. And then I can add another node pool called demo control, and I can could scale it up, but you can just run it at 1. So for production, scaling that up to 3 would basically give you, and this one to 3, and this one maybe to 2. This would basically give you an HA Kubernetes cluster. But for the purpose of the demo, 1 and 1 is fine. And then I can then create another node pool workers. And maybe you see, so this gives you a lot of control over kind of the scaling of your deployment. So you can choose different machines for your data store. You can choose different machines for your control, and you can then, depending on what are your requirements for workloads, you can have different configuration for the VMs or for the nodes that run your workloads. So making this a worker and bringing this up to 3. Yeah, so this will now create a new cluster. And you can see it's provisioning. So what does it mean? Basically, it talks to the DigitalOcean API right now, creates these nodes with a set configuration, and then it runs all the Kubernetes components on top of that. Yeah, so this is the cluster level. While that is provisioning, are there any new questions, or should we just go on? Daniel?
Yeah, there's quite a few new questions. Let's just go with the last ones first, because they're all referring to what you're working on right now. Jarek asks, does Calico encrypt anything? Rancher 1.6 use IPsec, as I recall.
Yeah, so as I said, so Calico really, so in this case, we are using
Canal and Calico.
Yeah. So Canal uses basically the flannel, and I think it uses VXLAN, so that would be unencrypted. But I think flannel also has a IPsec option that you can use. Last time I checked, they were working on that. I'm not sure if it has already been merged, but yeah, basically you should be able to have also an encrypted network. Yeah. Okay. In the case of Canal, as I said, like the layer 3 in Canal is basically provided by Flannel, and then Calico is run on top of that, and just does the routing stuff on the layer 3. So yeah, but it should be possible.
Okay, great. So next question, Surendra asks, does Rancher support Weave and Contiv network?
Yeah, so out of the box, I think with GA we are not gonna support it, but as Weave and Contiv, they're all implementing the CNI, container networking interface spec. We will be able to plug them in as well. Yeah, so basically any network, any software-defined network that has a CNI plugin can be used then.
Okay. This might be outside the range of the training, so I'll let you decide. George asks, how do you edit a node template? I've created so many vSphere node templates. If you make a mistake in vSphere config, then you have to recreate it.
Oh, okay. I think this was just added. I think this was added in the last release, the possibility to edit. So maybe the version that he's using does not support it. So I think this is a new feature that was added in this release. So this should help him to edit templates.
Okay. Let's do a couple more, and then we'll move on. Surendra asks, does Rancher launch the master and worker nodes in AWS autoscaling group?
I don't think it uses an autoscaling group. Yeah, that's a good question. I don't think by default it uses an auto-scaling group to do that. I think it just launches them as normal VMs, EC2s.
Okay.
But they certainly bring that up in Slack. I mean, I think that is an interesting thing.
Okay, great. We'll do two more. Giovanni, or maybe two or three more. Giovanni asks, is it possible to version control the Rancher configuration? In other words, infrastructure as code.
Let me think about that. I think the way that would be possible at the moment is, or maybe not at the moment, but I've seen people do that with using Terraform, for example, and we actually maintaining plugins providers for Terraform for Rancher, so that you can then use Terraform to bring up a Rancher node. But he was talking about the configuration. Yeah, that's a good question. Well, please ask it in the Slack channel.
Okay, great. Rosano says, since last week is available, new versions of Kubernetes version to deploy a new cluster. I think what he's asking is, how do you update the running cluster with a new version of Kubernetes as they're made available?
All right, okay, let's look at our cluster here. So if you're not running the latest version, I think what happens is, if you go here, you should be able to set. Yeah, I'm not sure if that functionality is in that version. So I think what happens, it should actually prompt you that there's another version available for that Kubernetes version that is running on the cluster. You can see right now we are running the latest available distro, which is 1.10.1. And I think this is happening here, where you can upgrade it. So it's similar like in Rancher 1. With the infrastructure services. You would get a prompt to upgrade it from here. Yeah. And you could also see, like when we created the cluster, we could actually choose from different distributions. So if you'd wanted to have like an older version of Kubernetes because of specific API properties, you would have done that, and then you could upgrade later on to that. Yep.
Cool. Kaushik asks if the HA Rancher 2.0 is available, and if so, can you show quickly how to configure it?
So we are going to cover that in an upcoming training, actually. So what the AJ mode means is running all these Rancher, because right now all the Rancher components are running in a Kubernetes cluster, but it's running in this container. So what AJ mode means is basically spin up a Kubernetes cluster that is HA. And for that, normally we would use our own Kubernetes installer, which is RKE. So this is this one. And then once you have that Kubernetes cluster, you would spin up all the Rancher components as deployments on that cluster. But again, we are going to cover that in the next training session.
Excellent. Okay, cool. All right, why don't you keep going?
Yeah, okay. So right now we can see that the cluster has been created. And so first thing we see now, which is also quite nice, you get like a unified view on the resource utilization in that specific cluster. So you can see all the CPU that is available in the cluster, the memory, and the pods. So why is there a limit here? That is just a default in Kubernetes. I think it's 110 pods per node that Kubernetes allows to run at max on a single node. And yeah, you can see the state of the components. And going over to nodes. So now you can see like how we have these different pools. So this pool runs our etcd. This pool is running all the Kubernetes components. And this is our demo worker pool. And yeah, so I would say let's go on to look at some other options that are available here. So this storage class is interesting. This will be interesting for you if you have stateful applications or databases that need to persist state. So what a storage class in Kubernetes does, it is kind of a provisioner for storage in your environment. So what that means, it's more obviously when you go here. Let's say you're running on AWS, then the storage class that you're creating, it it allows your workloads to request persistent volumes, and then these are dynamically provisioned as EBS disks in this case. And there are a lot of other options here. So it could even be NFS, yeah, or other stuff like OpenStack. So these are basically storage volume provisioners in the simplest terms. So this is what you're doing here. So this is done on the cluster level, and then in your projects, you're able to leverage these storage classes to provide persistent volumes to your workloads. Yeah, let's have a look at the tools section here. So as I said before, I think I have it set up in this other. Let's switch to our other environment here. Set it up here, get ready. Yeah, so this is already enabled. So this is new in 2.0. We basically make it very easy to set up a pipeline, basically to do something like from source to container. And this works on the project level. So let's go, if we go to the default project that was created here, and then go to pipelines, we can create a new pipeline. And this is currently linked to my GitHub account. So what you're able to do now is set up, like link to a repository, and then set up rules like which branch you want to run the pipeline on, tags and stuff like that. And then what this does is it automatically creates the webhooks in GitHub. And then when you, okay, let's just try to add that. Yeah, so then you're able to add steps to your pipeline. Like a build step would be, for example, you can have a specific language set here. So this is basically where you can run tests on your source code. And then another step would be a publish step, like building the image, pushing the image to the registry. And yeah, so this is an easy way to set up a fully CI pipeline. And going on, it will actually become a CI/CD pipeline, because it will allow you to not only build and test on Rancher, but also as a final step, deploy the workload to a staging environment or even to production. And let's go back to the cluster level again. Yeah, let's look at some of the other tools here. Another tool would be logging. So this is also one of the new features in 2.0 that I find pretty cool. These make it very easy to aggregate all the logs from your clusters and send them out to an aggregator like Elasticsearch, Splunk, and so on. So we even have like an embedded Elasticsearch, but if you have an instance of Elasticsearch running, you can just give it the endpoint credentials if necessary, custom log fields, and this then feeds all the logs from this cluster in your aggregator, logging aggregator. And another new feature is the notifiers. So first off, you have to create a notifier sync, which could be Slack, email, PagerDuty, webhook. And then let's just create a test and just give it a bogus URL. And then once you've set up a notifier, you can configure alerts. So there's a set of default alerts, basically checking the health of your Kubernetes clusters. And you can create new alerts and choose a specific system. So this is the cluster level. So these only does alerting for the Kubernetes components. You can set up an alert for etcd, for example, in case it loses quorum or stuff like that. And then you can choose a notifier. So test, this was the Slack notifier that I configured. And then this is going to be triggered when this service becomes unhealthy in this case. Yeah, so this was this. And then, so we are on the cluster level. Yeah, I've looked at the nodes already. Yeah, you can dive down to each individual node, check the health of these nodes. So this all comes from the node API from Kubernetes. They collect a lot of stuff about basically the state and health of your nodes. And yeah, so let's go to project namespace. Okay, so this is something that I need to talk about. So Kubernetes provides this concept called namespaces, which basically allows you to kind of isolate workloads running on the same cluster. And we wanted to provide a really good experience for multi-tenant usage of Kubernetes clusters. So what was not possible in Rancher 1. Was take the same set of hardware, of nodes, and let different teams run their workloads on that without interfering with each other. So that's why we created this concept called projects. And project is basically a collection of one or multiple namespaces. And within a project, you're able to work on all these namespaces, and applications running in a namespace are able to cross the boundaries of a namespace. But if you add another project, then this is completely isolated. So there are network policies in place that prevent containers from one project talking to containers from another project. And of course, the people that are the users that are authorized for project A, by default, they cannot access project B. Yeah, so this is what basically gives you multi-tenancy. So right now, by default, you get this default project, and we can create a new project. This is what I told you before. You can declare the pod security policy here. You can also start to add members here. So for example, I could add myself as an owner, member, read-only, or even custom. And custom, then again, I can click together my roles that I should be authorized. Yeah. So this is basically how you spin up a new project. And then the users that are authorized in there, they're able to access it. And they're gonna be using the same underlying nodes resources than in the default project. Yeah, okay, so are there any questions?
Jan, there are several questions. So let's just start at the end again, since it's most recent to what you're working on. Troy asks, with the pipeline feature, will you add Bitbucket as a source provider in the future?
Yeah, I think for GA, it's going to be just GitHub, but I think it's just a matter of figuring out like the API differences in Bitbucket. So I've actually heard other people requesting it. So, I mean, do a feature request on GitHub is what I can say. But I think it should be easy to do, and we're gonna probably add that.
Awesome. There's quite a few questions around what Rancher will support in the future, and that suggestion of doing a GitHub feature request is a good one for everyone who's asking about what we will support. Marco asks about the projects and namespaces. Namespaces just isolate on network level on the same node, but do pods still share the same kernel?
Yeah, that is true. Yeah, that is kind of, I would say, the one limitation of the whole container game, is they all come down on sharing the same kernel. So if for some reason, like like a kernel security vulnerability, one container can escape this container, it could possibly affect others. Yeah.
Okay. Okay, moving on to logging questions. George asks, is there a paper trail for logging? And Jarek asks if there's any support for FluentD.
You mean paper trail or a paper trail?
It just says paper trail for logging, question mark.
Paper trail for logging. Yeah, maybe you could
Expand on that.
Clarify that. Yeah, the question. I'm happy to answer it.
Cool. And what about FluentD support?
I think FluentD is actually in there. Let's see. Well, what we do is, I think we're actually running the FluentD daemon. This is actually the one that collects the logs from the pods, and then we configure it in a way that it sends them to the aggregator. So FluentD is running on the pods as soon as you set up logging here.
Okay, great. Okay, I'm going to move on to other topics. Here's one from Scott. He asks, is it possible to receive webhooks from other sources, such as Circle CI or any SaaS provided CI, to deploy into a Kubernetes cluster?
Yeah, I don't think I don't think we have webhooks in this version, but we do have in 1.0, so I think this is probably coming back. In the meantime, you can probably do it by using an API call to the Rancher API. So I'm gonna come to that in a moment. We still have a full-blown API, so the whole UI that you see here is all backed by API. So you're able to talk to that API, and the API is actually much more easier to deal with than the vanilla Kubernetes API. So it's much easier to do stuff like upgrade a service with a new image if you hook it into your dev pipeline and do stuff like that. So out of the box, I don't think we have webhooks at the moment.
Okay. And on that note, actually, we did just publish an article on webhooks on our blog, so that's a further resource if you want to check rancher.com/blog for the latest. Another topic on Nginx, and Andreas asks, why does a cloned container like Nginx have the same port number, even though I changed the port number during the deploy workload window? Not sure if that's a bug or what, but what do you think, Jan?
Same port number. So I think that would same port number. So that depends if you have like a cluster or node IP port. Is the node IP port what he's talking about? I don't know. Maybe clarify.
Okay, so yeah, Andres, if you could clarify that question. I'm going to ask one from Stefan. The CPU. This is about the range indicators. The CPU memory pods performance graphs have a blue bar and a range indicator. What does the range indicator actually indicate? A high and low watermark for a time period?
Yeah, I think it's max and min over a specific time period. But I couldn't tell you the interval or the time period that is used to calculate that.
Okay, cool. Let's just do a couple more. Tim Webster asks, is there a page in the UI that shows what pods are running on each node?
I don't think there is. So I think it's all about going to the workload level, and yeah, I don't think there's a page like that we had in Rancher 1.0.
Mm-hmm.
We can just look at the nodes. I think that is kind of the Kubernetes way to look at stuff. Yeah, don't care about your nodes basically. You just care about just care about your workload is running at the given scale.
Yeah. Okay, Tim, maybe you could make another GitHub request for that page to come back. Let's see.
We can maybe go on. Oh, okay. Yeah,
do you want to go on, Jan? Yeah, we can go on.
Let's take a question.
Okay, so there's a few questions about will Rancher provide an integrated way to back up etcd nodes of both Rancher and Kubernetes? And maybe you could also just talk a little bit about recovery, disaster recovery, stuff like that.
Yeah, I think this goes a bit above that training. Okay. But again, if you post that question in Slack, happy to answer you there.
Okay, cool. Do you want to go on then?
Yep. All right. Okay. So let's go into one of our clusters in the default project here. And you can see that the UI changes now that I dive down to the project level. So this is kind of like what would have been an environment in Rancher 1. Let's start by deploying a workload here. So you get kind of the same user experience. So you can use the UI to deploy workloads. You can use the API. You can use Rancher CLI, or if you prefer, you can use the kubectl, which is the native Kubernetes API client, to do that. Yeah. So just have a look. So this looks a lot similar to 1. So you define the image that you want to run, give it a name, the scale. Let's start with a port of 1. Choose the default namespace. Yeah, you can add port mappings right here. So if you do a load balancer here, this would actually mean an external load balancer. So this would provision like an ELB, depending on if you are on AWS. The node port, as I said before, would just assign a random available port, and then you can connect to any of the nodes in your cluster on that port, and it would forward the traffic to that application. And the host port, again, that is would just open the port on the node that the pod is actually running on. That's a bit less useful, I would say. And the cluster IP just makes that application available internally as a kind of internal load balancer. Yeah, and then you can set environment variables. You can define affinities for your scheduling. So as I said before, you can tag your nodes, like for example, depending on what CPU they have or what IO they have, and then you can make sure that, for example, your database is deployed on a host of high IO, and other like bulk applications use the cheaper VMs. And you can also set up health checks like you did in 1. Volumes, and the upgrade policies. So this is where you say that you want to have a rolling upgrade where the new pods are started while the old pods are still running, so traffic, so they can still like finish doing their work, or doing it the other way around. Yeah, so this should listen on port 80 by default. And yeah, so let's see what it did. So you can see, so these are the pods in the workload. So I had them at a scale of 1, and there's one running right now. This is the eternal IP address. And like in 1, you can interact with your containers by doing view logs. I don't think this one logs anything. Yeah, it does not. But I could do like execute shell and do stuff in the pod itself. Clone it, view an API. And yeah, so now right now this is running, but it's not, you cannot access it. So no traffic is forwarded to that application. So the next thing you're going to do is to go to the load balancing tab and add an ingress. which is basically a load balancer. And I think in this version, we leverage actually Nginx as a load balancer. So in 1.0, we used HA proxy under the hood. So let's just call this LBI. So here's where you can like define path-based routing rules, host name-based rules, and stuff like that. And in this case, I've just used the Hello application that I created before. I know it's listening on port 80. And you can also add SSL certificates. So this is pretty similar to the load balancer experience in 1.0. And yeah, I think that also addresses like maybe the question that we had before. So this is where you can define all these rules. Yeah, so the load balancer is running, and when we go back to workloads, it actually gives me indicator where it's running. I'm not sure why it's running on the other ports right now. That is really strange. So let's just see here. Why does it even have SSL? That's strange. Oh, okay. Apparently they provide SSL. Okay, so yeah, so I guess what happens is that this image actually defines a different set of ports in the image. And I think it just automatically mapped those to different ports. So this is the image, and what we can do now is we could scale this up. So if you go here, scale this up to 2, for example, and you can see that it's already done that. And and then when we refresh this a couple of times, I don't know if it does like sticky sessions around robin. Yeah, so we got we hit a different container this time. So yeah, so that's the load balancers. And yeah, then you have also service discovery, where you can add custom records into the DNS. So you could create internal names pointing to an external service, for example. Yeah, do more advanced thing with aliases and stuff like that. So basically, this injects additional records in the internal DNS. And again, the internal DNS is different from your external DNS server that you're using in your environment. The internal DNS just has the records of all the pods, of all the services in your environment, and are used for service discovery. And yeah, so that is this. And we can also have a look at the volumes at the moment. So this is the catalog. The catalog has changed a bit because we are now using Helm charts, basically the native Kubernetes way to create these catalogs. And at the moment, our community catalog is still pretty small compared to 1.0 catalog. But I think we have here, so this is something you could play around if you don't have like a infrastructure storage. You could use the NFS provisioner to kind of mock this dynamic volume provisioning. So just going to show you, if you deploy this service, it will create an NFS provisioner and a server on all the nodes, and it will register itself as a provisioner. So when you go back to the cluster level to storage, you can see that it created a storage class, Rancher NFS, and then you can use that to create volumes, persistent volumes for your application. So test volume, choose the namespace, and then choose that storage class, and you can request a certain size of the volume. Yeah, you can either dynamically provision a new volume or use an existing one, and then create that, and then you can attach that basically to your pod. Yeah, let's go quickly to config maps. So basically, this is the new way to provide configuration to your applications, as opposed to just like declaring environment variables. So all of this is key value based. Yeah, so when you create it, maybe too fast, each config is bound to a specific namespace. I think, let's see, if you add a new config name. Yeah, so the config is bound to a specific namespace, so only workloads in that namespace are able to access that config, which obviously makes sense because you want isolation between your projects. And another one is secrets. So this basically works like configuration, like config maps. The difference is, I think, that these are by default stored encrypted, and I don't think you can really attach them as environment variables. So secrets will always be provided to a pod in a mounted volume, which is basically using a temp file system. So it's not really written to the node. It's not written to the host itself. It's in a temp file system, which makes it more secure. So this is where you would set up credentials or certificate keys, stuff like that. Yeah, so I think we're good for other questions.
Okay,
or for the final questions.
Yeah, we have 38 questions, Jan. So
Okay.
I know I'll ask, and you just you can answer or say like, hey, submit this one to Slack. It's a little beyond the scope of the training. Okay, and I'm going to start at the beginning. So if you're still on, now's the time to listen up. So Jarek asks, can I make a load balancer driver? E.g., I want to deploy my own load balancer based on traffic or TRAE-FIK using my VPS provider API.
Yeah, you would certainly do that by deploying it as a deployment in the Kubernetes itself, and then because so you need to create like an Ingress provider, and this one needs to implement the Kubernetes API to register itself there. And but I don't think that you can then use the UI to add the Ingress. Yeah, so basically, out of the box, it just works with the built-in Nginx one. Yeah, but that's certainly a good feature request to be able to select the type of Ingress provider that you want to use. Yeah.
Awesome. Okay, so going to the next one, Surendra says, can we set up Rancher 2.0 in high availability mode as a native application instead of running it again in Kubernetes?
I don't think that works because Rancher 2.0 is leveraging the Kubernetes API to store its own resources. So it's done. The way we do it is that we define custom resources in the Kubernetes API to store our objects in there. So it really needs Kubernetes. It really needs to run on Kubernetes. That is the answer.
Okay. Next one, Gabriel asks, how do you run backups and how does Rancher do disaster recovery?
Yeah, I think that kind of plays into the other question that was asked. I think we should maybe make this part of another training to cover the backup and recovery.
Right, I agree. Okay, noted everybody for our next training. Okay, Scott is asking, what networking stack does Rancher 2.0 use? Calico, Weave. I believe you answered that already.
Yeah, so going back, I mean, we can just quickly go back to the global view. When you add a new cluster, that is basically where you define what kind of networking you want to use. And again, this might just be the UI, but generally all the network providers that use CNI should work. So I guess in the future you will get more options here, like Weave. So we are pretty good friends of Weave, so I think this will be integrated in the future.
Okay, great. Next one, Scott asks, how does Rancher OS itself scale? In other words, if Rancher OS is managing Kubernetes, it must be running somewhere else, either on VMs or an existing Kubernetes cluster. What's the recommended setup for a Rancher OS management cluster?
Rancher OS is our own operating system, like a tiny, small Docker-based operating system. It does not really, it doesn't really manage Rancher. It runs any kind of Docker workloads. So I'm not quite sure about the question. Yeah, maybe if you could clarify.
Okay, great. Or ask on Slack too. Next one, Tim Webster asks, could you touch on the different CNI implementations and why you would choose a particular one over another?
Oh, so I think we talked about this right now. So right now we have Canoe, Calico, and Flannel. I think it's just because we are still in beta that we don't have like a whole bunch of other ones. But again, I think going forward we will add the most popular our CNI providers in there.
Okay, great. Next one, Ben Allen asks, are there plans to add two-factor authentication support for something like Duo?
Duo, I don't really know what Duo is. But I think it's really a question of what auth provider you use here. So if your auth backend has two-factor authentication, then it should also work here. So like if you set up something like single sign-on ping identity, as you're able to in one dot, you will get two-factor authentication. But I'm not sure, maybe I misunderstood his question, so please clarify or ask on Slack.
Okay, cool. And I'll just make a note because people are adding more questions. I think we're going to cap the new questions, so we'll try to get to all the ones that have already been asked, just because of the time. And if you have additional questions that you haven't posted already, then you can respond to either the email that goes out after this call with the recording, or ask on Slack or the forums. Okay, going to the next one. Martinez asks if you can demo with vSphere. Not sure if there's time for that, or you already did that.
Yeah, I don't really have a vSphere cluster that I can demo on, but we can have a look at the. Let's check if that is enabled. So if you go to the global view, so these node drivers are basically what does all the provisioning on different things, and you can see that the vSphere provider is actually active. So this should be available if we try to add a new cluster. So, it's not different to the other stuff. Interesting thing. We should probably, yeah. So we need to create a node template, and then you get to provide all the configuration options like the vCenter and your credentials. And then basically this is the profile that you request from vSphere, the CPU, disk, memory, and you could probably switch that to Rancher OS or any other URL. Yeah, so it should work.
Okay, great. And the next question, if you could just leave it on the screen, Rosano asks, this option to deploy new clusters seems quite different in Rancher 2.0 than 1.x. There's no option to set numbers of nodes and select a template.
In 1.0, there is no, to this number of nodes. Oh, okay, so this is all happening here. So let's go back to the DigitalOcean one because I have configured that. So this is where you choose the template. The template contains your credentials, and it contains, he's probably dialed it later. So the template contains the credentials. It does not store the credentials, but wonder what I passed in here. Yeah, so the template is where you define, what kind of droplets in case of DigitalOcean you want, okay? And then once you have that template set up, when you go to clusters, add cluster, let's just say you have an existing cluster for the sake of it, edit cluster. So now I want to scale up that cluster. I want to have more nodes. And this is where you define the number of VMs that are provisioned additionally. Yeah.
Awesome. Okay, great. Next one, George asks, correct me if I'm wrong, but we should not run boot to Docker in production, correct?
I absolutely agree.
Yeah, okay.
That's why I said you should use Rancher OS.
Okay, great. Yeah. Do you want to give it a reason, or good?
Boot to Docker was never made to run in production. It's just something you play around with on your local dev machine.
Okay, great. Awesome. All right, let's go to the next one then. So David says, does Rancher bring some features that make it easier to manage stateful applications on top of Kubernetes, STS, PV, PVC, etc.?
Yeah. So some of the things that make it easier is that you can manage it so easily to set up these storage classes and stuff like that. In addition to that, if you go to add class, you can actually see that one of the options here is Longhorn. And Longhorn is our own implementation of a distributed replicated storage. And this is currently, I think it's still in alpha, but when we're going to release that, what this will give you is how do you call that? I can't get the name right, but this allows you to run basically a distributed storage on top of your nodes in the same cluster, and yeah, and then it should make it very easy to provide your application with persistent storage.
Okay, great. Next question. Peter asks, is it possible to briefly cover the steps to create a custom cluster with virtual machines?
Okay, sure. So let's go to clusters. Yeah, let's go to the global view. Add a cluster. And I think he meant like custom machines. So this is where it goes. So basically what this means, it skips all the provisioning. It does not talk to any cloud provider API. Okay, so it assumes that you either have already provisioned your bare metal or that you have some kind of provisioning system, custom provisioning system, where you create VMs in your own network, for example. And then basically what you have to do when you create your custom VMs or your bare metals, all you need to do is install Docker, and then as a last step, you're going to run the command that the UI generates for you. So and here I've set custom. So let's click on save. All right. So now it's similar to Rancher, one dot. You get a Docker run command with a Rancher agent. And here is where you say, okay, so I want this to run on my etcd host. And then another command for my control plane, or maybe both. So this gives you then a node with the control plane or with etcd, and then you have this worker command, and then you use that on any machine that you want to hook into the cluster as a worker. You run that Docker command, and then that node is registered into that cluster. Yeah.
Excellent. Okay, thanks for going through that. The next question, Dan asks, once a new version of Rancher is available, how do I upgrade it without losing data?
So right now in the beta version, upgrades and rollbacks are not yet supported because it's a beta version. In the GA, if you run it from the Docker container, like we did here, it will be you would have to bind mount the volume that has I think the way it works, you will have to bind mount the volume that has the etcd data and then just basically do a Docker run with the new image version, attaching that same volume with the etcd. Because again, all the state of Rancher is also stored in etcd. So yeah. So basically, because the way that we are leveraging the Kubernetes API, everything gets stored, like all the settings you do here, they get stored in etcd. So in order to migrate or upgrade, you need to preserve the etcd. And I think that's the way it works for a Docker container. But again, this falls into the broader topic of like backup, disaster recovery, upgrades, and stuff like that.
Yeah. The next question is sort of similar. Agus, I believe it says, the asker is, I made Agus set to 1. And the question is, I plan to use 2.0 for production. Is it possible to install the current review first and later on upgrade to the stable version?
Yeah, I don't think, as I said, rollback and upgrades are not supported in the beta, so I would not vouch for that. It might work, but again, I don't want to vouch for it.
Right. Okay, cool. So next question, George is clarifying.
So maybe that also falls in the question when we will go GA. Maybe you want to talk about that later.
Yeah. Do you know, Jan? I believe it's in May, like in the middle of May. But what do you?
So if you can hold off for I don't know, 1 or 2 weeks, then you can probably use the GA version.
Yeah, it should be around the corner. Okay, George asks about using papertrail.com as a logging provider.
Okay, yeah. So I think I think we had that question before, yeah. So Papertrail, I think Papertrail supports syslog as a log format. Let's just quickly check that. Yeah, you see. So we have a syslog sync, and you should be able to give the Papertrail endpoint. I think they use ports to separate users. So you should be able to just configure your Papertrail endpoint here, and then the logs will get shipped there.
Yep. Okay, great. Awesome. Okay, cool. So glad we clarified that. Thanks, George. Okay, Jarek asks, can I use FluentD on the pods to stream logs to my Graylog?
Okay, so as I said before, we deploy FluentD in order to ship the logs off of the pods. So FluentD is already running. Yeah, I'm not sure about Graylog. I mean, it's not here in the UI, so I guess Graylog is not supported at the moment. So I think that's a good one for another feature request then.
Yeah. Okay. Cool. So feature request for Jarek. Okay, Enos Afghan. Sorry if I'm butchering your name. Asks, is the Kubernetes dashboard accessible for a cluster?
Oh, that's a good question. I think we are not running the dashboard because we have the awesome Rancher UI. So
yeah.
I don't think it's running because the dashboard is. I think the dashboard is running basically as another deployment on top of Kubernetes, and I don't think we enable it because I mean the Rancher UI has all the features of the Kubernetes UI and much more. So yeah, but you can probably just deploy it in a project as a deployment. You can just run the Kubernetes UI if you want.
Okay, cool. That's a good workaround.
I mean, that's one of the things with Rancher. It's so versatile.
Right. Awesome. Okay, good. Okay, so next question. Andreas is clarifying a question from earlier. He says, I published a port for an nginx container and cloned it. Port is 30924, for example. Then I clone this container, and even changing the port number, it still ends up being the same port. Is this a bug, or do I need to change some network settings?
Okay, so I assume, so let's go to this.
He says it's on a custom installed cluster.
Let's go to this project here. So I'm not quite sure where he configured another port. So it might be that he uses the port mapping here. Yeah, I mean, it might be a bug, or it might just be a limitation of Kubernetes that you can't really change, that you can't change the port after the fact. Yeah, please ask in Slack, or I mean, if you think, even create a ticket in GitHub about it.
Okay, cool. All right, we'll go on to the next one. Ujwal asks, will Rancher support external load balancers such as big IP F5?
Well, that I think out of the box, it depends if there is a node. So okay, so the way it works with Kubernetes is when you create a Kubernetes cluster, Kubernetes wants to know where it is running. And in order to leverage like a cloud provider infrastructure service like load balancer or storage, you need to tell basically Kubernetes, okay, this is I want to use AWS as a cloud provider. So in the case of like an on-prem solution like Big IP, you would actually have to have like an implementation of Big IP as a cloud provider, and I don't know if that exists. Maybe that exists in Kubernetes, but certainly not. But there might be. I mean, certainly not in the Kubernetes version that is shipped, but there might be some cloud provider out there that does it. But yeah, as I said, so you need to have a node. You need to have a cloud provider plugin for Kubernetes that knows how to create a Big IP. Or how to interact with the Big IP API. Yeah, out of box, I don't think neither Kubernetes nor we do it. But yeah, please open a feature request.
Okay, cool. Next question: how does one make Rancher OS interface you are demonstrating highly available? I think you kind of covered this already. Did you not?
The interface, yeah. So again, the interface is running off of the API, the Rancher API, and the Rancher API is running currently in a Kubernetes cluster that is not highly available because it's just it's just running on one node. Okay, so in order to make the UI high available, you need to make the Rancher API high available, which means that yeah, you basically need to scale that installation above one node. And again, I think we have a training scheduled for that already.
Yeah. Okay. Ujwal asks, does Rancher 2.0 support catalog items just like Rancher 1.6? Can we import our own existing custom catalog items? If
Yeah,
yes,
I think there was. Yeah, I think this is a question that came up often. So as I said, the format of the catalog has changed to use Helm charts, which is kind of like the Kubernetes catalog regime. And I think I don't want to promise too much, but I think I've heard that we are working on a simple way to convert the existing catalog, because the existing catalog uses Docker Compose files, and going on with Rancher 2.0, we are using basically the Kubernetes manifest. So I think there will be a way to convert an existing catalog.
Okay, cool. Jarek, next question. Jarek asks, when you add an ingress and set the port, do you set the port on the container or on the load balancer? I'm not sure.
Okay, so this is the port, the target port. So this is the port that your your application is listening on. And then yeah, and then again, like with all the port mapping that Kubernetes does, the port that is published on the node is allocated dynamically from a pool of I think from 30,000 to 32,000 or something like that. But this should be the target port of should be the port your application is listening on.
Okay. And on this note, so Dan asks, when he creates a new ingress, he says, I can only set rules for the services that are within the same namespace. Is it possible to have a global load balancer like I used to with Rancher 1.6?
Okay, that's interesting. Yeah, that's actually a very good question. So I'm just gonna believe him that it's not possible. It should be possible to do it. So maybe it's just an UI thing in that beta version, because technically there shouldn't be anything preventing it, because the namespaces are not the namespace within a project don't have network level isolation. So it might be just a UI thing, but this would actually be a good thing for a ticket on GitHub if these other services don't show up here.
Awesome. Okay, good question, Dan. Thanks. And he asks another one. It's an example. It says, having domain example.com and a single Hello World app, where do I point the domain? The master of the cluster? I'm not sure.
Oh, okay. So let's see what we have here. We created Ingress previously, and oops, why is it not available here? Huh? Refused. Maybe something changed with my network. Okay. Let's look at this one here. Okay, so this is the URL I get, and I think if you look, if you look at the other nodes, all of these nodes should also expose it. Yeah, so basically you can go, you can go to any of the hosts. So what you would do, let's say you have another external load balancer for, let's say, SSL termination, or you have, you just want to update your DNS records, you can actually add the IPs of all the nodes in that cluster. And then hitting that same port that the Ingress configured will get you to your service.
Awesome. Okay, Jan, we only have 10 questions left, so we're just going to cap it at that. Hopefully finish in the next 5 minutes here. Just to wrap up. Manuel asks, is it possible to start and stop workloads?
So I think pause orchestration, this would prevent Kubernetes to reschedule, and but the pods would still be running. So basically you could delete the pods, and then Kubernetes would not try to recreate them. It actually does. Huh, that's interesting. So yeah, it's very adamant to try to keep this the desired state. Yeah, so it's possible that it just doesn't work in the beta, because this is a beta version again, and some things don't work. But if you think that that this is maybe a bug, then please feel free to create a ticket.
Okay, cool. Sertan asks, are there any specific considerations regarding WebSockets and the load balancers? And I'm just going to say to review the recording, because we've talked a lot about WebSockets and load balancers, and you can ask a more specific question.
Yeah. So yeah, I cannot go too much into detail. It's a pretty detailed question. But again, the load balancer that is provisioned here uses Nginx under the hood. So if Nginx is able to handle WebSockets, they should not be necessary to. Yeah, it should work out of the box, basically. I know that with HAProxy, it works out of the box. I'm not sure if Nginx supports WebSockets, but yeah, I would wonder if they wouldn't do it. But yeah, that's something to check with the Nginx.
Okay, cool. Gabriel asks, can you deploy Rancher in Azure in an existing VNet?
That's a good question. I mean, I don't use Azure at all, but I think what I would expect when you create your template, anything about VNets here? It doesn't look like there's an option for VNet. So again, if this is possible at all, so Rancher uses a library called Docker Machine under the hood to talk to all these APIs. So it might either be just a limitation of the UI that this is not exposed, or the Docker machine, like the library doesn't support it. But please just open a ticket that you want to be able to use existing VNets.
Yeah. All right, I'm moving on. Scott asked, does Rancher have support for HashiCorp Vault backend?
Yeah, I think we do, but again, it might not be in the beta. But I think the goal is actually to integrate with Vault, so that the secrets are not stored in etcd, but the secrets are actually stored in Vault. I think that's a goal. I don't know if it's going to be available in the GA. That's going to be released in May, but yeah, please ask in Slack. I can't give you an answer when it will be available.
Yeah. Okay, great. Scott asked, if you use Amazon EC2 as a cluster type, does it provision a brand new VPC or integrate with an existing one?
Yeah, I think that plays a little bit in the same question as for the Azure. Again, I don't have credentials. So I mean, if you use this, put on your credentials, and then if it don't asks you to select the VPC, then it does not. But I think actually, like in Rancher 1. I think it was possible to select the VPC. So it should be possible here as well. Yeah.
Okay, cool. And then I think the last question I'm going to take, and we can just put the rest on Slack, is, do worker nodes need to be accessible from the internet for an internet app?
Well, the worker nodes need to be accessible from the internet, depending on whether you have any applications that you want the internet to access. So if you don't have, for example, let's say you're running an AWS, you probably, I mean, you don't have to, but you might want to leverage the Elastic load balancer. In that case, all the ingress traffic from the internet goes through the load balancer, and no traffic should hit the worker nodes directly. But in other cases, you might want to expose like a workload that is running on a worker node to be accessible directly. In that case, of course, you need to open that port. And Kubernetes always uses, by default, uses ports above 30,000, but you can also specify a specific port that you want the application to be exposed on.
Awesome. All right, Jan, I'm gonna end the questions there based on our time. Thanks everybody so much for your questions. I'm gonna take control back of the presentation and just finish up with our last few slides. All right. Okay. Thanks again, everybody. Let's go back towards the end here. Whoops. Let me get our last slides up. Cool. Just so everybody knows, we have mentioned this channel a lot. Slack.rancher.io. Can you see my screen, Jan? Is it showing?
Yeah, it's showing.
It is. Okay, good. So slack.rancher.io. And rancher.com Kubernetes also on our website has a ton of information. And if you do have questions, you can put them or just like to say thank you and what your experience was on this webinar. You can tweet out the hashtag Rancher K8s, and we will see that as well. I want to make sure my slides are actually coming through. There we go. And then finally, we have an ebook deploying and scaling with Kubernetes that's being updated for Rancher 2.0. So that is yet another resource you guys can turn to. And like I said at the beginning, everything is recorded from this session. So you will be getting that in your email along with the slides. So that's all we've got. Thanks so much. And Jan, thanks again. Awesome presentation. Great job answering all these questions.
Thanks everyone for taking part.
Yeah, thanks everybody. All right, we're signing off, and we'll see you soon.